जय हिंद सभी को। आज हम लोग एक इंटरेस्टिंग टॉपिक लेकर के यहाँ उपस्थित हुए हैं। हमारा आज का टॉपिक है व्हाट इज़ अ वेक्टर क्वांटिटी। तो क्या ज़रूरत है वेक्टर क्वांटिटी की, ये थोड़ा डिस्कशन का मुद्दा है। व्हाट इज़ द नेसेसिटी ऑफ वेक्टर क्वांटिटी। Let us take an example. If I am guiding my friend, you have to reach a point, suppose A, and he is standing at point B, and this is north direction, this is, rest are understood, this is south and so on. If I tell my friend to reach the point A without this, and which is at a distance of 10 meters from B, and my friend is standing at B. So if I told my friend reach a point A at 10 meters from B, can he reach? So he can move in this direction to 10 meters, he can move in this direction in 10 meters, he can move in this direction in 10 meters. So there are infinite directions in which he can move, but only one is the correct direction. If I tell my friend you have to move in north direction 10 meters, then definitely he will reach the point A. So friends, here is the need of vector quantity. So friends, we reach to a conclusion that a quantity with magnitude and direction is called vector. So to represent a vector, we need a directed line segment. The directed line segment has initial point and terminal point. So the point from which it begins, that is called initial, and the point at which it reaches and terminates, that is called terminal. So it has a finite length because it is a line segment. So, and it has a direction. Length of this line segment represents the magnitude of the vector, and the direction of this line segment represents the direction of the vector. Now let us come to next thing, that is called direction angles of a vector. If I take the XYZ system, the three-dimensional system with three mutually perpendicular lines x, y, z, and take a vector, it makes some angle with x-axis, some angle with y-axis, and some angle with z-axis. Obviously, positive direction of x-axis, positive direction of y-axis, and positive direction of z-axis. The angle formed by this vector A with the positive direction of x-axis, suppose it is alpha, with the positive direction of y-axis, suppose it is beta, and with the positive direction of z-axis, suppose it is gamma. So alpha, beta and gamma are known as the direction angles of this vector A. So the word is direction angles. And direction angles for the vector A are alpha, beta and gamma. The angle formed with positive direction of x-axis, y-axis and z-axis respectively. So this is your direction angles. Now next thing is direction cosine. So if I put a perpendicular from here in this xy plane, it will fall somewhere here, and if I complete this diagram in this way, so we have these perpendiculars here, and let us complete this diagram. So you can observe a cuboid in making. So a cuboid is formed. You can see all these are perpendiculars, and this figure now full of information. And we need another diagram to represent our information. So let us take the plane in which this vector A and x-axis is there. So if I take that plane, suppose I am taking xy plane, or I am taking, so I am taking a plane in which x-axis is there, origin is there, and this vector quantity is there. This vector A is making an angle alpha with x-axis. So I have dropped a perpendicular also. Let us evaluate the cos of this angle. So cos alpha will be equals to base upon perpendicular, that is OP upon magnitude of A. Secondly, OP is the x component of this vector. The projection of a vector on x-axis is its x component, on y-axis is its y component, and on z-axis is its z component. And these x, y, z are called a scalar component of a vector. So this we are getting cos alpha equals to OP upon, and suppose this point A has coordinates x comma y comma z. So this OP will be equal to x. The modulus of A is given to us, suppose it is r. We assume that mod of A equals to r. So you have cos alpha equals to x upon r. Similarly, you can find out a plane which contains the vector and y-axis, and in that case you will have cos beta will be equals to y upon magnitude of vector A, that is we have considered as r, and cos gamma will be z upon magnitude of vector A, that is r. The value of these values, cos alpha, cos beta, and cos gamma, are called direction cosines. Also, we assume the magnitude of vector A. If a vector has this point has coordinates x, y, z, and if I take I cap as unit vector, along x-axis, j cap as unit vector along y-axis, k cap as unit vector along z-axis. In that case, this vector A, which has the point A has coordinates x, y, z, it will have the scalar components as x, y, z, and vector components as xi, yj, and zk. And this vector A can be represented as xi cap plus yj cap plus zk cap. Now let us move to another thing. So in this case, the magnitude of r will be under root magnitude of vector A, that is r, it will be equals to under root x square plus y square plus z square. Now let us come back to this. So what is cos alpha in this case? cos alpha will be x upon under root x square plus y square plus z square. After putting these values, we will get the cos alpha as x upon under root x square plus y square plus z square, while cos beta will be y upon under root x square plus y square plus z square. Similarly, cos gamma r is equals to z upon under root x square plus y square plus z square. These quantities cos alpha, cos beta and cos gamma are known as direction cosines. These are called direction cosines. And they are also represented by L, M and N. Now let us one fact, what is the value of, let us evaluate this, what is the value of L square, M square, N square? L square plus M square plus N square. What is its value? So let us put the values from here. You have x square, this is also we have written as x upon r, y upon r, z upon r. So I have put the value of r in this case. So you have x square by r square plus y square by r square plus z square by r square with you. R square will be your LCM. In the numerator you will have x square plus y square plus z square. And r square will be equals to x square plus y square plus z square. So in place of x square plus y square plus z square, we replace r square and you will get 1. So very important fact is derived, that is L square plus M square plus N square is equals to 1. A relation between direction cosines. Now next thing is direction ratios. For any given vector A equals to xi cap plus yj cap plus zk cap, the direction ratios are the numbers which are proportional to the direction cosines. So if we have a vector A with xi cap plus yj cap plus zk cap, then the direction ratios are any three numbers A, B, C which are proportional to the direction cosines L, M, N. So if you have ABC proportional to L, M and N, then A, B and C are direction ratios. These are direction ratios. So what we have? We have A upon L is equals to B upon M is equals to C upon N. This is the condition for any three numbers to become a direction or ratio of any vector. Let us examine this carefully. If you remember, you have L equals to x upon r. You have M equals to y upon r. You have N equals to z upon r. Can we get the values of r from here? R is equals to x upon L. Any doubt in this? From here, if I evaluate r, it is y upon r. And if we evaluate from here, it is z upon n. Sorry, it is y upon m and it is z upon n. Now you can see that all these three ratios are equal to r. So you can conclude x upon L is equals to y upon m equals to z upon n. So what is conclusion from here? X, y, z are always proportional to L, M, n. So for any given vector xi plus yj plus zk, x, y, z are direction ratios of vector A. So I hope today we have learnt about direction angles, direction cosines and direction ratios. Also we have learnt what is the scalar components of a vector, what is vector components of a vector, and unit vectors along positive direction of x-axis, y-axis and z-axis.